Now let's think about that falling coffee filter. Let's say that this is the coffee filter at the instant it's released with velocity 0. What forces are acting on the coffee filter at the instant of release? Well, there's no longer anything holding it up, but the weight of the coffee filter, which is its mass times the acceleration of gravity, is acting downward on the coffee filter and accelerating it downward at 9.8 meters per second squared. That acceleration is not going to last, as we can see clearly by watching a coffee filter, but that's what we have at the first instant after release. Now, the coffee filter falls, it picks up some velocity. What happens to the forces? Well, gravity is still exerting the same force and will continue to exert the same force on the coffee filter as it falls. Gravity doesn't care how fast the coffee filter is falling. But the faster the coffee filter falls, and we're indicating here that we have some v that's not equal to 0, so the faster it falls, the more air resistance it's going to get. Now this r vector here represents the air resistance. So because of this velocity, we have some air resistance. And that air resistance reduces the effect of gravity. It does not reduce the gravitational force, it doesn't reduce the weight, but it reduces the effect of the weight by fighting it. So air resistance fights the weight, and now the coffee filter accelerates more slowly than before. Still, it continues to pick up speed, and at some point it's going to be going even faster than it was here, and we're going to have correspondingly more air resistance. So that at some point the air resistance is actually going to get big enough to balance out the weight, and the net force on the coffee filter will reduce to 0. And what's that mean? Well, that means since there's no net force, there's no acceleration. The coffee filter stops accelerating, and then we say it's at its terminal velocity, because since it's not accelerating, its velocity is not going to change. Now technically, we approach terminal velocity, we never really reach it. We just keep getting closer and closer. But for practical purposes, at some point we can be said to reach the terminal velocity. Now let's consider a little more specifically what happens to this filter. Okay, the filter's falling. It has a weight, it has an air resistance. So we have weight down, air resistance up. There's a net force. The weight is being reduced by the amount of the air resistance to give us this net force. And of course the acceleration is the net force divided by whatever the mass of the object is. Now if the magnitude of the weight is greater than the magnitude of the air resistance, we conclude that the acceleration has to be in the direction of the weight. So the acceleration is certainly down in this case. Now as velocity increases, the weight stays the same, the air resistance increases, the net force decreases. Notice we have less net force here than we have here because we have more air resistance here than we had here. And we have an even smaller acceleration than we did here. So the acceleration is going to continue to decrease, giving us less and less change in velocity. As the velocity increases, the air resistance increases, and eventually we're going to reach a point where we have 0 acceleration. We could look at a series of snapshots of a falling object. Weight, lots of weight, little air resistance. Net force is pretty close to the weight. A little more air resistance, the net force is reducing a little bit with respect to the weight. The weight is unchanging, as said before. The air resistance is increasing, so the net force and therefore the acceleration is decreasing. If we draw a graph of the acceleration versus time, the graph might look something like this. An acceleration close to 9.8 meters per second that at some point rapidly decreases and then starts to level off, because in any time interval, the smaller the acceleration, the less velocity change, and therefore effectively the less change we have in the air resistance. As the acceleration approaches 0, the velocity change approaches 0, so that the velocity approaches terminal velocity.